Today we are starting our unit on circles. The essential question is, how do I use the properties of circles to find missing measures? My learning intention: I'm learning the parts of circles, their properties, and how to apply these properties to find missing measures. You've got two warm-up questions. One is the segment addition and the other one is angle addition. Please solve for x and find all the measures on your segments. Then you know that the measure of angle AOC is 74. Find x, find the measure of the two smaller angles. So, pause the video and try to do the warm-up problems on your own. So, as I'm looking, I hope you tried and you're just checking your answers. I know AF is 29 plus 2x plus 8. And that is going to be equal to x plus 27. Any questions on how we set it up? Okay, let's combine like terms. 2x plus, what's 29 plus 8? It would be 37. Check it with your calculator if you're unsure. And that will equal x plus 27. Okay, now I'm going to subtract x from both sides. X plus 37 will equal 27. Subtract 37 from both sides. X is equal to negative 10. But wait a minute. I thought we couldn't have a negative length. Well, we know we can't, but what happens when I substitute negative 10 in? So to find the measure of df, that is x plus 27, which is equal to negative 10 plus 27, which is equal to 17. So this one is 17. The quickest way to do this is the whole thing 17. If this is 8, 17 minus 8 gives me 9. 9 plus 8 are 17. The other way you do it is to sub in again. So we would have 29 plus 2 times negative 10. And that would equal 29 plus negative 20, which would give me 9. Either way it works. Okay, for the angle addition problem, we know that the measure of angle AOC, the whole thing, is 74. So we're going to find x and we're going to find the measure of the two smaller angles. To find x, we know that when we add them together, we get 74. So 74 degrees is equal to 3x minus 4 plus 5x minus 2. Collect your like terms. 74 is equal to 3x plus 5x is 8x. Negative 4 plus negative 2 is negative 6. Now I'm ready to solve for x. I will add 6 to both sides. $80 is equal to 8x. Divide by 8. And 10 is equal to x. Now, multiplying by 10 is very quick and easy. So the measure of angle AOB is equal to, here's AOB, 3 times 10 minus 4, which is equal to 30 minus 4, which is 26 degrees. Now we could take 74 minus 26, or we can sub in a second time. For the last angle, that measure of angle BOC is going to be equal to 5 times 10 minus 2. Just substituting in the 10 for my x. That's 50 minus 2, which gives me 48 degrees. And that should be x should be 10 degrees. Okay, now let's get ready for vocabulary. We have a lot of vocabulary, and you will be tested over it. First vocabulary word. What is a circle? A circle is the set of all what in a what that are equidistant from a point called the center. Well, it is the set of all points in a plane that are equidistant, that means the same distance from a point called the center. What is a chord? A chord is a segment, line segment. Whose endpoints lie on the circle. So picture a circle and just a line going from one edge of the circle to another. That is what a chord is. Okay, think about what the diameter is. A diameter is what? Well, it's actually a chord that contains the center of your circle. And as we keep going, we've got central angle. What is a central angle? A central angle is an angle whose vertex is the center of the circle. So picture a circle, see that point in the middle? Any angle that comes off of that point in the middle would be a central angle. An inscribed angle. This time, the angle's vertex is not in the center, it is on the circle. And whose sides contain the chords of a circle. And what is part of a circle? An arc is part of a circle consisting of 2 points on the circle called the, guess what they're called? Endpoints. And all the points on the circle in between them. An arc is part of a circle consisting of 2 points on the circle, which are called your endpoints, and all the points on the circle that are in between them. An arc, a minor arc. We've got minor arcs, we've got major arcs, and we've got semicircles. Think of the word minor. Minor means smaller, so if you're looking at that set of smaller arcs. An arc of a circle whose points are on or in the interior of a central angle. The measure of the minor arc is equal to the measure of the central angle. From minor arcs, we go to a major arc. Now, the minor arcs, you're in between, you're on the inside, the interior of that central angle, or that angle. So a major arc is an arc of a circle whose points are on or in the what? Interior was minor. Exterior is major. An arc of a circle whose points are on or in the exterior of a central angle. The measure of a major arc is equal to 360 degrees minus the measure of that central angle. Okay, so semicircle. Semi means half. So a semicircle is half of a circle. A semicircle is an arc whose endpoints lie on a diameter. Its measure is how many degrees? How many degrees are in a circle? 360. Divide it in half, and you get 180 degrees. So, wow, I've heard that before. Where have I heard 180 degrees before? The degree measure of a straight angle is 180 degrees. The sum of the interior angles of a triangle is 180 degrees. Now we find out that the degree of a semicircle is 180 degrees. 180 degrees is quite popular. Adjacent angles, think of our adjacent arcs. Think of our adjacent angles. Adjacent arcs are arcs that have a common what? Endpoint. An intercepted arc. An intercepted arc is an arc whose endpoints are the endpoints of two chords. So just like we had segment addition, we had angle addition, we now have arc addition. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So if you're looking at the measure of AB, we're looking at this measure here. It is AD, the measure of AD plus a measure of DB. So you get that whole thing going on. So let's put it into practice. We've got this circle here, and if we're looking at the first problem, we know that AB, so this part here would be 40 degrees. And BC, this part here is 60 degrees. And we want to know what is that whole length. So we would have the measure of arc AC is equal to 40 degrees plus 60 degrees. 40 degrees plus 60 degrees is 100 degrees. Okay, what happens if we know the whole length, that AC, what if we know the whole thing is 130? And we know that AB, this little piece here, is 38. What do we do? If we know the whole and we have one part and want to find the other part, do we add, subtract, multiply, or divide? Well, we subtract. So this would be 130 degrees. So the measure of arc BC is equal to 130 degrees minus 38 degrees, which will give me 92 degrees. Any questions? It's pretty similar to what we were doing before with the angle and the segment addition. The sum of the pieces is equal to the degree measure of the whole thing. That looks a little bit better. Okay, now the last theorem we're going to look at is what we call the inscribed angle theorem. The measure of an inscribed angle is equal to 1/2 of the measure of its intercepted arc. So if you're looking at the measure of AB and the measure of angle ADB, the measure of this angle here, the smaller angle, this is the angle we're talking about, is equal to 1/2 the measure of this arc here. So 2 times this will give me my outside piece. If I've got my outside piece, I divide by 2. So we've got 2 problems here. Each time you will either multiply by 2 or divide by 2. If I am looking for my degree measure right here, I'm going from the inside out. Am I going to multiply or am I going to divide? I'm going to multiply by 2. So the measure of arc GH is equal to 86 times 2. The measure of arc GH is equal to be 160 plus 12, it'd be 172. 86 times 2 is 172. So this is 172 degrees. Okay, but what about the next one? What do we notice? Well, we notice that this part is 62. I'm looking for this here. Here are my sides of my inscribed angle. Am I going to multiply by 2 or am I going to divide by 2? In this case, I will divide by 2. So the measure of angle X, Y, W is equal to 62 degrees divided by 2. The measure of angle X, Y, W is equal to 31 degrees. This one is 31 degrees. Guess what this one is also going to be because they have that same intercepted arc. It's also 31 degrees. Isn't that crazy? It's crazy, but that's the way it works. They have that same intercepted arc, so these 2 angles are congruent. I know I'm successful when I can find missing measures in circles with arcs, central angles, and inscribed angles. So you need to know what a circle is, what a major arc is, what a minor arc is, We need a central angle. And that inscribed angle. Make sure you are studying your vocabulary.